So I've been asked to summarize what we've learned or what we've talked about in the last three webinars. And I think all of you know or have heard me speak. I could probably speak for the 2 hours and talk about, just continue to talk for the next 2 hours and tell you all about what we've learned. But I was encouraged to limit it to distilling down the top five. So here's Dave's top five of what we've learned in the last over the last three webinars. So number one, crisis drives change. So we've been told by Peter and the Swedes that the advances to net zero were achieved in Sweden were all started with the Arab oil crisis of 1973. And we've always talked about Europe's advanced status in energy conservation as a function of high energy prices. Well, unfortunately, North America's time is coming. The economy, our post-pandemic economy is expanding rapidly. We're seeing supply chain issues that's leading to rampant inflation. We now have a war in Europe that's involving a major energy producer, Russia, and we're seeing that gas prices in Ontario, gas prices at your local pump are all now jumping to highest levels that we've seen. So we know that energy or the cost of energy is changing in North America, and no longer is North America the world of cheap energy. We know that as the war progresses and they're talking about limiting gas from Russia, is using economic sanctions, we know that what this will drive is more the use of more LNG and more liquefied natural gas that can be shipped by ships across the ocean. And as that happens, then what we'll see is we'll see that North America's energy systems become a global, our natural gas systems become global and not just a regional North America system as they are today. And what that'll mean is we'll see higher natural gas prices. We're also seeing the impacts of climate change, severe weather, weather disruptions. It's more and more in the news and more that's being talked about. And that's led to a carbon tax and policy to how to cut our carbon. And what we've seen is in the last year or so, a jump in carbon tax rates and the numbers going up and the taxes going up every April the 1st, they increase. But what we've seen is a new law that's been passed and tabled in Parliament that talks about our need to reach net zero. And as this need, what we've seen is to get to our targets. In the last 8 years, we've accomplished, in the last 14 years, we've accomplished 9 million tons. And in the next 8 years, we have to accomplish 283 million tons. So what we can see is that there's going to be more policy, there's going to be more drive to decarbonization, and we're going to see, I'm sure, higher carbon taxes or higher measures to price carbon and make the transition to decarbonize to net zero more economically attractive. So that's lesson one. Lesson two is that building heating must be addressed. And we go back to our cartoon of the elephant in the room. We talk about all sorts of things about how to decarbonize, but very seldom do we talk about heating. Yet heating is the number one source of carbon in the GTHA. In Hamilton, it's number two, and it's only number two. It's number two only because of our industry. It's not number two because of better buildings. It's number two because of the high level of emissions from industry. But industry is doing something about it. They're decarbonizing. They pledged this. So what will happen is unless we do something with our buildings, the pie will rebalance and the buildings in Hamilton will grow. The GTHA or the GHG contributions will grow with time. And we don't want that to happen. So we need to address building heating. So that's lesson number two. Lesson number three is the pathway to net zero carbon. The 3 C's of net zero carbon: conserve, connect, convert. We know that in conserve, we must reduce our demand for energy. In other words, turn off the lights, turn down our thermostats. It also means using energy more effectively. We know that our second step will be to use integrated energy networks and gain all the advantages of them. And our third thing will be to convert and eliminate the fossil fuel. Now, I think all of us always want to jump to the answer first. And I think that the idea of electrification and putting Teslas in all our driveways and moving forward with that as our decarbonization step is really as appealing to all of us. But let's look at what happens as we switch to electricity. Well, Climate Institute of Canada has just put out a graph that shows what will happen as we electrify. And now, the electrification is only one part of decarbonizing and eliminating the fossil fuel sources. There's renewables. We talk about geo exchange, but that needs heat pumps, and heat pumps are electric. We talk about solar PV and the use of solar thermal. We talk about RNG and that renewable natural gas, which is coming on. We talk about hydrogen and biomass, all these things being fuel sources to drive us to net zero. And we've also talked about in this series industrial residual heat. But if we look at this graph that's been put out by the Climate Institute of Canada, we can see that for a household, they're predicting that our energy source will mostly go to, by 2050, will mostly be electricity. Now, it's interesting to note in this, it doesn't show the households using less, it just shows this transformation to electricity. So what does that mean? Well, what it means is it means a lot more generation. So what the Climate Institute of Canada, again, on an overall Canadian perspective, looks at it and says, well, we're going to have to grow our generation by 3.4 times. So we're going to have to build a lot more power plants. But not only do we have to build a lot more power plants, we have to build them faster. And we have to build them 6 times faster than we've ever built them before. Now, when we look at our new energy supply mix and what we'll be building these power plants to be fueled on, they'll have to be zero carbon. So there'll be solar, wind, hydro, and nuclear. And we've all heard the stories about conventional nuclear and the refurbs that are going on in Ontario to make sure that the base load fleet of nuke plants in Ontario that are still will have life and will continue on. But we're also hearing about SMRs, small modular reactors, micro modular reactors, MMRs, and we all hear about nuclear and the growth in this. But hydro and nuclear are not easily permitted or built. And that will be getting then. So we have to go 6 times faster, yet we're entering into technologies where the permitting process has been slow and has been problematic. So not only do we have to generate a lot more power, we have to get it to everyone. So transmission and distribution will need to be upgraded. And the Climate Institute talks about how we're going to have to get smarter. And we've already talked about digitization. But when we talk about getting our distribution systems and getting the electricity to the consumer is smarter, we also have to realize that there's physical constraints, and that's in the wires and the voltages. And so there's things that there will need to be upgrades to transformers, to cabling, and all of these things will cause great disruption to our communities. And the last thing that we know is that electricity is expensive. And you can see in the graph on the lower right that gas remains the cheapest source of energy. And even with the carbon tax, it's still a cheap source of energy, even to the large industrials that operate at very preferred rates if they can peak shave in Class A. In Class B and the consumers, the numbers are just a multiple. So electricity is expensive. So having said that, maybe just simply jumping to the last step and converting and making everything electrical isn't maybe the best step. Let's take a step backward and go back to conservation. So in conservation, what does that mean? It means using less, turn off the lights, turn down the thermostat, but it also means getting the most out of every joule, watt, or BTU. And we see from a study that was published in 2013 that Canadians waste 66% of the energy they use. So they only use 34% of every watt that they buy. So this represents tremendous potential. So energy sharing and getting using up that, increasing the use pattern from 34 upwards and using part of that wasted 66% is key. And that comes from energy sharing and harvesting. It means increasing our efficiencies. It means using more heat pumps for electrical heating. But the bottom line is that we cannot continue to waste this much energy and decarbonize. We'll never decarbonize wasting this much energy. We have to use less, and we have to use it smarter. So one of the ways that we can do that is to use integrated energy networks. And what are integrated energy networks? Well, they're the highway for energy. And what's important about them is that they future proof our energy systems. So when we're providing energy through a network, what it means is we have central generation of the energy and we can switch how it's generated. So we can generate today, for instance, in a district energy system, we can generate with natural gas, and tomorrow we could use industrial residual heat. And what we don't have to do if you're connected to a network is do anything to the individual building. We can do it centrally and in one place, and that's very important. And what we've heard from our in this series and from Sweden is that there's not a lot of technological changes to integrated energy networks. We can go great distances, greater than 50 kilometers. We can service large markets. Beijing, we've heard about. We've heard about Sweden, the large cities there. We've heard about New York City, large district energy systems. So large markets and populations can be serviced. We've heard that the digital and the data and digitalization of these networks and the uses of artificial intelligence and machine learning, they'll transform the solution to the 21st century and they'll make it more effective and more efficient. And one of the things we've learned along the way is that probably the biggest challenge to all this will be resourcing the talent and getting the people ready for a net zero economy. We also know that they're the lowest cost to decarbonize. And we know that we can integrate electrical data and thermal networks, and most importantly, they can be complementary. And we can use electricity where it's best suited, not universally, and therefore limit the amount of electricity that growth that we need to do. So, lesson 4. And this perhaps to me is personally my biggest lesson of learning, and this is something that going back, reflects my past. I've lived a life in the world of cheap energy. And energy conservation projects were always put against the standard of economic payback, and it was always important and it was always difficult to get energy conservation projects through because what it was energy was cheap, and you had to save a lot to make it worthwhile to put the cost of the infrastructure in or to make the changes. So a lot of projects to conserve energy didn't go forward. And when we started this journey with the Chamber of Commerce and I was helping the team out, it was always there that I was concerned that when people would ask, but is there value in this? We can only do things if there's value. We need to receive value for our waste energy. And that will only drive us working on this project. And I would look at it and say, well, I think there's a social aspect for the industry, and I believe there's a carbon credit play, but I was never sure that we could ever get to the point of saying that there would be a money flow or a revenue stream. And then thanks to Peter and this series, my eyes have been opened and we've all learned that there is value in residual heat. And we were introduced to Helsingborg, Sweden, and Orsenkraft, which is their district energy provider and or their energy company, and one of their products is district energy. And we know that of their district energy that they provide, 35% of it is industrial residual heat. And it comes from a chemical plant that's in Helsingborg. And they've been doing this for 40 years. And it's a Kemira chemical plant. And Kemira and later on, Emma Gunnarsson from Kemira is going to be talking and answering some questions. But Emma told us how this revenue stream that they receive from Orsenkraft has kept that chemical plant in Helsingborg. And it's made it because Kemira is a global company and they have to compete globally in the chemical business. And that plant had to have an extra advantage to be able to stay in Sweden. And they got that with industrial residual heat. And that was a very important lesson, and we look forward to it. And that's one of the things that we want to get into in our next phase with a feasibility study is putting that business case together and valuing the residual heat and putting this together so that we can drive this forward and have an economic sustainable solution. So that's lesson 4. So lesson 5 is that policy will be required. And I guess we just can't wait for the economics of high energy costs and carbon taxes to change the economic playing field and then have everybody play catch up. Because buildings that are being built today will have a life of 50 to 100 years, well past 2050. And unfortunately, many of these buildings that are being built today are still being built with conventional technology. Gas boilers are still going in, high temperature solution systems are still going in, and these will limit or make it very hard to decarbonize in the future. So what we need is we do need that policy to advance green buildings until energy prices show that it makes sense. Now we were talking to a good developer yesterday and an enlightened developer, and they in their minds have already got that business case. They're building green buildings and green developments, and they say it's not they're not doing it to be good citizens or good corporate citizens. They're doing it because it makes economic sense to them, and because they're in it for the long haul. And unfortunately, they're in the minority of that type of developer or that type of thinking in the building industry. But we need to change that. And to move that along, we need policy. And one of the things that the city of Toronto has pointed out is that by enabling district energy systems and district energy solutions, it actually makes it cheaper for building owners to decarbonize, because decarbonization comes cheaper at bigger scale. So if you can establish that bigger scale of low carbon heating and cooling, then what you'll do is actually make it advantageous to join that network and advantageous to get to that decarbonized state. So that's lesson 5. Policy is required. So in summary, just summarizing and going back, what is the Hamilton advantage? Well, decarbonizing heat is difficult. Heat is the elephant in the room. So it's not going to be an easy journey. What else have we learned? Industrial residual heat is a tremendous opportunity. That 66% of the energy that we waste has to be used, sits out there and can be used, and is this great opportunity to not burn more gas or burn more oil, but to actually use use already more of what we are burning. We also know that Hamilton has lots of industrial residual heat or waste heat. So we've got the resource. Hamilton has the backbone. It has a thermal network. It has a district energy system. It's been in place since 2002. It's community owned. And what's important about community ownership is it indicates stability. One of the fears of someone connecting to a district energy system is, will it be there tomorrow? Because the building that they're committed to being on district energy has no heating system. So it has to be depend upon a third party. And for people that depend upon the third party, they want to make sure that that third party is stable and will be there. We've learned that electrification will not be cheap or easy. That yes, electrification is an important part of role in moving to net zero carbon, but that it won't be necessarily it won't necessarily be there or be a cheap solution, nor will it be an easy solution to accomplish. And lastly, we have a made in Hamilton solution to a GTHA challenge. And what we talk about is we have the potential to use industrial residual heat to enable 80 million square feet of buildings in the GTHA or Hamilton to be net zero carbon heated. And this 80 million square feet comes from the 4 million gigajoules of residual energy that were uncovered in the Chamber of Commerce TAF report. And we believe there's more. We believe there's more residual heat, and we believe the potential is greater. So that's that in roughly 15 minutes is a summary of what we've learned or what we've seen.